We can break our text down into something known as Ngrams to check our pre-processing, as well as explore the contents of our data or create new features for machine learning. An Ngram is simply a sequence of neighbouring n words or tokens, where n can be any number. In order to do this, we'll import three packages: the NLTK package, the pandas package, and the matplotlib package. Now let's create some tokens for this example. These tokens haven't been fully pre-processed. We'll come onto that in our next practical lesson. So let's copy our tokens over and then print these out to have a look at what we've got. So we want to take our tokens and look at the uni-grams that are present in this data. A uni-gram is just a term for when n equals 1. So we want to create a pandas series, so we use pd.series and then run nltk.ngrams. This takes two arguments. The first is the tokens and the second is the value of n. So here n equals 1. At the end of this, we'll append our value counts, so it'll look through all the uni-grams and count them up for us. When we print this out, we can see the most common uni-grams. So in this case, it's our most common tokens, our most common words. We can see that the word to appeared 7 times, the word of 6 times, the 4 times, etc. And you can imagine how different this would look once we finished our pre-processing and removed our stop words. We can also put these into nice charts and visuals for uses in presentations. So if we take our top 10 uni-grams and then use .sort values, then .plot, followed by .bar h. We want to use a horizontal bar for this. Then we can use some arguments to make our graph a little bit nicer than the defaults. So we use the colour of light salmon, we specify the width, and we specify the size of the plot we want to produce. Of course, we also need to give this plot a title, so we'll call it the 10 most frequently occurring uni-grams. So we print that out and we've got a nice chart we can use for presentations and for discussing with different stakeholders. We can then compute our bigrams. Bigrams is just a term we use when n equals 2. So we'll be looking at the common occurrences of neighbouring pairs of words. It's the same piece of code, we just change n to 2 and rename it as bigrams. So we can see here that the bigram that were appears 2 times in our data. The rest just appear 1 time, so we don't need to plot this out. Again, we can compute our trigrams. So you may guess this is just when n equals 3. So we're looking at 3 tokens that appear together. And here we are. We can see that these different trigrams only appear once, so again we don't need to plot this out, but when you're working over much bigger data or data that's been through more thorough pre-processing, this bigram and trigram analysis can give some really interesting results. Just another note on terminology, we've got the phrases uni-grams, bigrams and trigrams here. When n is any more than 3, we just use the phrase ngrams to refer to this. So now we've got this done, let's jump into our practical and put everything we've learned in this section together.